after I said that. I don't mind saying it on YouTube, though. Sometimes I embarrass myself in that I will look at um, something one way and realize later, why did you do that that way? That was so brainless of you. All right, going to find um, that. I think I might have closed it. So, Guy, if you can, maybe stop the recording. I'll go hunt it because I apologize. I was not quite ready. Uh, I have it closed, even though I can get to it pretty quick. Oh, silly me. I've put it in our book area so I can get to it right away now. Excellent. And this will be fun. I think you guys, this just turned out so well. But I want you to know I'm with what I'm going to show today. There are certainly other ways to go about it. I'm just getting my screen ready so it's easy to view. And sorry for my background noise, but we've been dealing with some family drama surrounded around cars. We bought a new used car, and give me. Is my background noise okay, guys? Is it high? My wife's talking angrily on the phone. That's why I asked. Is the background noise?
When you speak, it's okay. But when you are keep silent, we listen to what Sue says.
Okay. I don't dare go and tell her, Sue, you got to be more quiet because she's really going to town on someone right now. I hope you haven't started the recording yet, though. Hang on, I'm almost there. I'm trying to get the view to be. I have forgotten how to. There we go. Excellent. Okay. I will start sharing and we will just hope. Hang on, I'll just ask. Okay, Sue agreed to talk quieter and she didn't get mad at me, so we're all safe. Okay, guys, now you could start the recording. Sorry for all that, guys. And I will share my screen too.
So we are ready.
Excellent. There we go. Excellent. Okay. So last week, Guy showed us a lot of great Python, excuse me. Did I share? Share. There we go. Guy showed us a lot of great SQL statements. But what we want to do is within Python, or you could do this within R and other languages too, but what we want to do is automate the use of SQL from inside our primary language. And as you know, we go through Python here. I'm going to do a control K1 here. Oh, control K2. There we go. Now, these are all the methods of this database table ops class that I've created. And I want to show you each of these functions. So of course, we have the init method, which is what we use when we're instantiating this. And by the way, with this particular class, you wouldn't necessarily need to instantiate, but I still like to do that because there are cases in my particular work where I might be working with multiple databases at the same time. So that's why I chose to do this, but there are types of classes you can do, a non-factory approach, where you're just using the class without instantiating it, and that is just fine, without creating an instance of it, without creating a copy of it. So in the init class, this is probably the busiest one. And the reason it's so busy is because I wanted to make these operations super crisp in the way they generate the engine down here. And I'll explain what I mean by that. So if, for example, you install Microsoft SQL Server Express 2019, which is the latest free version of SQL Server that you can find, you'll see that you'll get a connection string, probably exactly like this. Now, I want to point out that if you're doing a deep back-end process where nobody can get to your code, in my opinion, this is absolutely safe. But if you're allowing some front-end access to your database by users and the operations are needed, you probably want to do some type of username and password and encryption at this level. But let's understand this portion of it right here, where we're just saying a trusted connection. This is where we're trying to just do development, just make sure the operations work. If you're a fan of the pragmatic programmer like I am, Dave and Andy, their 20th edition of that, 20th anniversary edition of that excellent book, they talk about tracer bullets. And I would say this code is a great starting point to where you go deeper. You can start from this code and leverage from it, but as far as the way it's connected to, that might need to be changed to where this stuff is passed in encrypted or something like that. Now, at this point, we take these elements and we build up a string. Now, you have not, I think you've all seen me do this before, but this is so elegant in Python. I'm building up a connection string, and then this server is passed in from here. You see them co-highlighting here. And that's going to be, this is going to be put into here. The only reason I'm doing this plus equal is so that I don't have a long unreadable string. So I just would rather do it this way. And then now I'm building up the string piece by piece. So there's the driver, the server, just replacing those in the way I passed them in the trusted connection in the database. Now, why do I do this part? It is very hair-pulling, frustrating, annoying to build up these strings correctly. What we pass in to the SQL Alchemy.create engine, again, this is one of the ways. There's other ways, but SQL Alchemy engine, we're importing from that, we're importing the URL. We're also importing SQL Alchemy. But at this point, I'm using this one because I want to create an engine. I need this connection URL or a connection string of some kind. I found it really hard to get the right string. In fact, I couldn't do it. 1 second. So once I went to this connection URL method, it just magically worked. And it was easy to automate. So that's why I'm going into such painful detail about this. If you'll take the time to import this extra feature and create it from this connection string that you built up, it will work like a charm all the time. Now, you still have to add this part. It basically is saying what flavor you want to use. And you can see that this stuff is built a bit on PyODBC, which I found very interesting. But we're also creating this dictionary element of ODBC Connect. Now, I can anticipate for you new people, whoa, Tom, this is making me dizzy. I want it to not make you dizzy. Let me go over it at a high level now, because we just did the details. We're passing in elements. We're building up this connection string. We're just creating a URL. This is just syntax. I don't want you to make too much of this. I had to look this up in the docs and just go, oh, okay, that's how you do it. This is just the way the programmers did it to generalize it. So I wouldn't make too much out of trying to make sense of this. It's just what you have to do. And so now, though, we have this connection, this agreement, more or less, with this engine. And it's not really open full time, it's available. It's saying, oh, when you need to use me, I'm here. And that's why we're saying self, because now I can use this engine in all these other methods. So that's going to be the most painful explanation. Are there any questions at this point? Okay.
I have a question.
Yes, Guy.
Yes. First of all, SQL Alchemy engine, is it available for any kind of database engine? That means it's depending on the environment that we are passing and what kind of connection thing we are building, then we are able, that means in this case it will be considered as ORM, object relation management library.
Correct.
Okay.
Correct, Guy. In fact, all you would need to do is change this part according to my understanding. And when you go to the SQL Alchemy documents, which are actually pretty good, when you look through the parts about how to connect, they will show you for different flavors of SQL. Like the most common one is Microsoft SQL Server. And now that they make the Express version free, and the Express version will do quite a bit, and they also make the Management Studio free, which is an incredibly good visualization tool. Even though you guys know I don't tend to be a big fan of Microsoft, I love SQL Server. It's great. But then you can go do MySQL, PostgreSQL, and I think you can do Oracle too. So they cover a wide range of things for SQL Alchemy. Does that cover it good, Guy?
Yes, perfect. Now I want to highlight one point only. I think if you are going to Oracle, we have also to download Oracle client for each machine using this. It's something related to the Oracle settings. It's not important in our class, but this is the only difference. Even if you have ORM, it's a little bit more complicated to deal with Oracle for security reasons. This is just a highlight for who want to use it with Oracle. That's all.
I think Guy's point is so important. You could land in a role somewhere. You have to remain flexible. Each database has its own little peculiarities. Each type of SQL is what I mean. So, and the other one I didn't mention is Sqlite, which actually comes installed with Python. So I think you can just use it directly, if I'm not mistaken. Okay, so we've got the main thing to remember. All I want you to remember is we built this. That thing is ready and waiting for us to connect to our SQL server anytime we want. Okay. Now, you notice that I use this little acronym frequently in my code. It's just called query. It's QS query string. And I'm building up this ahead of time. Let's see. I'm looking for something here. There is something I'm a little worried about here. I think this may not be the latest code, so maybe we'll have to troubleshoot that. This will be okay. But I'm looking for the existence of a table and with this code. And so let's say I've got this query string. I've got this F in front of it. Now I want y'all to notice another cool thing if you didn't know about it. I'm using the triple quotes so I can do a multi-line string. You can still use F for formatting things inside here. And I think when I run this, we're going to have an error. And I'm going to try to force myself to troubleshoot it real time. But it's possible too that I think I might be remembering this wrong. I think the main thing is table names used right here. It won't be used here because why? Because I don't have it inside my curly braces. So I think it's just doing an alias there, if I remember my SQL right. And so this is just very generic query to get all the table names. Then I look through to see if I get one match to a table name. If this, I'm jumping to this, forgive me. when we've done the query, here's how it's returned right here to the cursor from this connection. You know what? I'm going to back up. I got ahead of myself because I forgot something. So we pass in only table name. And this query, I don't even need this F here because I'm not passing in any variables to this, but I left it there to be flexible. Now here's the most elegant part of this whole class. When I say with, that's invoking a context manager in Python. What's beautiful about context managers is it's saying, I want you to use, 1 minute. So this is basically saying connect as this, but with the with, it's handling everything under this block. It's saying open a certain way, operate a certain way, and then close the connection. So it will actually close the connection when this block is through, which keeps everything safe. That way you don't have this dangling open connection. So with this connection, we execute this command right here. We turn this using SQL Alchemy's text method. We operate that query up here. And so to the cursor's an iterator. It's like a list of things, but it only lets you look through it once and then it's gone. So we're going to look through it once. We're going to say for a possible table in the cursor, if table name equals T1. So each T is actually some tuple returned in this cursor iterator. And it's just going to look at the first element of that tuple because I know ahead of time that's where the table name occurs. And if that's the case, it will put a T here. Otherwise, it won't. It has to be equal. Now, by turning this into a Boolean, I'm doing a bunch of steps at once. I could have said if table exists, return true, else false. But this is just a shorthanded way to do that because if this list is empty, if the table name wasn't found, it'll be empty. And by typecasting it to a Boolean, it'll be false if it's empty. If it finds one or more, and it only find one, it will say, well, it's true because the list isn't empty. And so that way I can check for table existence. Now you may be thinking, why do you care about checking for table existence? Well, when I create a table, I don't want to create a table if it already exists because that would cause a problem in SQL. So I pass in my schema string for the table I want to create. We'll look at one of those in a minute, but just trust me, it's a string that tells you how to create the table. And so I create the table name. In the schema string, I know that if I split that into an array, if I split it, and when you don't put a parameter in the split, it's assuming white space. And I know that in the rules of SQL statements, when I'm creating a table, it's going to be the third element, 0, 1, 2. That's where the table name will occur. And so I go in ahead and say, if the table already exists, then just return. The table's already created. I don't even return anything. I just say, go back to the calling function. But if it doesn't exist, I do this context manager over and over. And this is the most repetitive thing in these methods that we're going to look through. And it says, okay, you want to execute, take SQL Alchemy's text method and turn this schema string into something you're going to pass in. It's really that elegant and simple what SQL Alchemy does for you. Okay, so now we create that table, and I'll show you a schema string when we go over to the instance where we call this stuff in and start using it. Now, what if I have to drop a table? Well, if the table doesn't exist, That's why we're multiple times using this table exists method. If that doesn't exist, just return. But if it does exist, okay, let's go ahead and drop table name. And you can see now, yes, in fact, I'm passing it in. Why do I have the triple quotes here? I don't need them. I just did it from habit. So we could actually eliminate those. Okay, again, these context managers are beautiful. You've seen it used with, for example, opening files. If I said with open file name as a write or a read as F, then I do whatever I'm going to do while it's open. It'll actually handle the closing and all of that just with this statement. Yes, please, Guy, go ahead.
Yes, about the context manager, I want to mention something here. Let's say when you are connecting to the database engine, for example, the connection string, it has to be open, and then when you finish, it has to be closed. Otherwise, if two connections from the same client to the server appeared, this might cause a problem in utilizing the engine. Now, using this context manager, what will happen? The connection will be open in the life cycle of this context manager. That means once the let's say the query or the instruction is finished, then it's done. It will be closed automatically. That's why it's very valuable tool.
Thank you, Gaithan. We can't say enough good, really, about context managers. They clean up our code so much. They make our code beautiful. If you guys are fans of Mark Harmon, he's a huge guy in the Python community, and rightly so, because he teaches everyone how to write beautiful code in Python. And so if you're just feeling like you get to change gears one day, go look up a YouTube video of Mark Harmon presenting, and he's a big fan of these context managers. But when we came up with these context manager, or when came up with, they cleaned up our code so much. Again, before we had to be careful, okay, open it this way, then do these statements, then here's what you do if there's a problem, and now close it. Well, a lot of functions like this engine connect, like open a file, Python has built-in context managers for them. But if ever you write your own function and it has operations of opening and closing and doing things in between, take the time to go investigate how to make your own context manager for it. It's worth the effort. You'll love it. Okay, so that's how we drop a table. Now, I hope following this init method, everything else looked really elegant, like, oh, wow. And again, there's just rules you have to follow when you're using someone else's code. So don't make too much of this. This is, with SQL Alchemy, which we imported, I got to call the text method and pass in this command string. So do you have full control on table create? Yes, Jonathan, we're going to show that in the schema method. Good question. I hate to say good question because that would imply if I don't say good question sometime, you didn't ask a good question. So I try to refrain from that in case I forget to say good question. And I'm just glad you asked that question is what I really meant. Okay, now here's where it gets super elegant. Okay, here's pandas up here. And what is implied here, and I probably should have spelled this out to be clear, this is a bad code practice. I'm just going to tell you, but for us data scientists, it's not, because just like we like to use PD for pandas and MP for NumPy, we like to use DF for short for data frame. Now, because we're a community and we're pretty consistent with DF, it's okay. But if you were really going to be very strict about great coding practices, you'd want to write out data frame. But we're taking license here as our fellow data practitioners. So I'm only passing in the data frame and the table name. And look at this. I take that data frame and I say to SQL in a table name, add it. Whoa. Now, if you've played with SQL at all, you're adding a complete data frame in this one simple statement? Yes. Well, where's your context manager, Tom? Thank you, pandas. I'm just telling you, here's my engine. I'm telling you how I want you to add the data. I'm telling you what to do with the indices, and we're going to go over that in detail. And it has its own context manager. Thank you, pandas. So super cool. Okay. Now I want to emphasize too, this is a starter file. This is your training wheels. You guys can take this for the rest of your lives and leverage it. And as there's cool updates, you can improve it. Okay, now query to data frame. I think I could improve this name, but here's what's going on. I'm passing in a query string, and I want it to return as a data frame. That's all I'm getting at here. So you can see it right here. I've got my context manager again. I'm saying, pandas, read SQL query. Here's that query string. Here's my connection. I want you to get it to me as a data frame. Oh my. Now, when Windows came out and I saw people learning how to use computers and they'd never used DOS, I felt bad for them because I wanted to say, you should use DOS for a while so you'll appreciate Windows more. And now I'm thinking, oh, you should have to do this without doing it this way. And those of you that have studied SQL a lot, I'm assuming those of you that are hardcore SQL students right now, you're probably looking at this. And if you know data frames, you're going, that just almost doesn't seem fair. The way I felt when people were learning Windows without learning DOS first. I'm like, no, you're missing the history. You're missing all this valuable stuff. But it's just that easy. And in fact, I could even just say return right here. I could replace all that with return this. Why did I leave it expanded out? Just so it would be clearer when I posted it. But for myself, I might be tempted to just do the return there. Okay. And then there's the update, the DB. So I literally pass in an update command because those can be quite specific. And it's usually a single row, a single record in the database. And so again, I use my context manager. I've got my connection. I execute my SQL Alchemy text in that command that I passed in. Okay. I'm wondering, let me see. If I think it might be better if I do 2 columns now. And I'm hoping this is all quite visual. I want to be over here. I think I can do this. Excellent. Oh, now I need to close that one up. Okay. And I would like, I don't know what I changed here, but that scares me. Can I move these? I think I can. Oh, I just want to, there we go. I'm going to, there we go. Excellent. And then I'll close I want to close this one and don't save. There we go. Okay. All that stuff that I just showed you over here. Keep being silly here. I want to, in there, open this one. There we go. I'll just keep them both open. Okay, so here's what we just looked through. And I'm going to, there we go. Now we can see more in each one. And since that one's narrower, I'll keep this one wider. Okay, we still have to import pandas because of stuff we're going to do. But now I'm just importing all of that we just looked at. And I'll take it back to this level. By the way, a quick way to do what I was just doing, Control K and then 2 in a sequence. That way it just shrinks a class down to the method names. Okay, my first thing, I'm creating a dictionary where I have a label and a list for each label. That is the way a pandas data frame is laid out. So, but it's not a pandas data frame. Here, it's a Python dictionary. Well, I'm going to take it to a data frame by going PD, short for pandas, alias for pandas. When we say as, just like in SQL, that is a alias. And then I'm going to call the data frame method to convert this data dictionary into a pandas data frame. And here is a very simple schema string for table creation. Now, why schema? Because we're actually creating a table and we're telling it how to treat each column of that table. So I want an identity, common abbreviation for identity column. And this is a particular way of saying this in SQL Server. This is one of the frustrating things. Different flavors of SQL will dictate how you say this part. But all I'm saying is start at 1 and increment by 1. So I could literally start at 0 and increment by 1, start at anything and increment by 2 or 3, whatever. Then there's primary key. I'm telling it it's a primary key. And then these values are integer and they cannot be null values. It will throw an error if you don't give a value for these when you're saying that when you pass them in as one of the things you're going to do. Then I'm pre-setting an update command where I'm going to say update table 1, where you're going to set value 1, again, value 1 to 7, because that will be different, you'll see. And because you can see here at value 1, I had 1 and 2, but I'm going to set some row in the future, I'm going to change it to 7, value 2 to 10. And which identity? The third row. Okay, now I've just got these prepared for this simple example. Now I'm going to instantiate with the class I created over here, right there. So I'm just up here, I said from this Python file, this Python module, import the DB table ops. And I just call it dbto in the instantiation. That way, every time I use this front end, I'm getting to the methods that exist in this class. So the first thing I want to do is just see, does table 1 exist? Now, I'm going to go ahead and bring this over since we've got it collapsed. And then I'm just reporting, does table 1 exist? And then I create it and I check for existence again. The reason I have this if true, it's just a way to say, I want to be able to collapse these to look at more things. And also I might want to change that to false after I've created these entries while I was developing to play with more things. So don't see any complication here. These are going to run. And then I'm going to say insert a data frame to the table. Which data frame? This one that we created up here. We'll just use it repetitively. And to which table? Table 1. And then I'm going to do it again. I'm just going to repeat it. And then I'm going to do an update on the third row that occurred. And then I'm going to do a query string, select everything from table 1. And then I'm going to say, all right, use the query to data frame method and pass in that query string. And then at the very end, I'm going to drop the table and I'm going to see if it exists anymore. So let's run all of that. Now, when you run, don't let the speed fool you. It will run faster in the future, but there's just some things it's getting ready the first time. Okay, here's what happened. Let's get everything balanced so we can see more. We don't need to see that. I just want y'all to be able to see as much. There we go, perfect. Okay, just like I promised, we don't need to look at this stuff that we set up here. So I'm going to scroll down as as deep as possible. Here's where we start to do things. The first thing, does the table exist? No. Okay, let's create it. Now let's check if it exists. Yes, now it exists. Okay, now we're going to pass in that data frame to table 1. And you can see that it passed it in. We've got 4 total rows. Now these values here, over here, those are the data frame indices, but these are the idents from the SQL table itself. And you can see we did the replacement, or the update, I should say. And then we dropped the table, checked its existence, and it's false that it exists. So this is a toy example, but I hope you can appreciate the power of the toy example, showing you that you can go to town with this. Now, another thing, as promised, and I hope I don't eat my words here. Oh, now it's running much faster. Well, yes, much faster. And it'll probably go much faster still. Now, I love PyODBC. I love SQL Alchemy. I also love PyODBC. The reason I love PyODBC is ultra fast, but we can make all this faster with a decorator called, 1 minute. There's something I plan to add to this whole class structure called PsychoPG2, and it makes all this run much, much faster. But for most operations, you won't see a huge speed hit. And if you use a different class of PyODBC, I think you would find for some operations that are slow with SQL Alchemy and where you don't need to load your data to a data frame, PyODBC takes a little more coding, but it's not a horrible amount. And I will create another class structure to illustrate that. So at this point, oh, let me check questions. Do you have full control on table create, like adding constraints? Absolutely, Jonathan. Whatever you put in this table schema, as long as it's good SQL syntax, SQL will obey it. SQL queries are pandas to explore the data. And where would you use both or one over the other? Exactly. That's what I was saying. It's a case-by-case basis, Jonathan, because sometimes you don't need a pandas data frame. It might be better to just use a PyODBC based query. And I can again, I'll create another class that illustrates that. That's the workhorse of my work for UL. I use PyODBC. I don't think I would really want to convert to this method in my UL work because I just don't need pandas data frames. Let's see. And where would you use both or one over the other? Again, Jonathan, it's a test it both ways and see which one serves your needs best. And that's a good question. I'm glad you asked the question. Can you explain what drop table is doing at the end again? It's just destroying, it's annihilating that table, Brother Greg. Is saying, get out of here. It's dangerous, by the way. You want to make sure, here's that command. Oh, wait. Drop table. Let's go look over here. It's so simple that I just pass in the table name and keep the command string in here for ease of use. But this will, it's gone. You want to be very careful if you're going to use that. And that's it in a nutshell. So again, this is very data frame to SQL and SQL to data frame centric. You could use SQL Alchemy without the data frames. So over time, I want to grow this and use it more. So something I can do is there's a lock feature. So there's a whole example I do that we're doing for our book. And with the time we have remaining, I think based on the questions and the interest in this, I think you guys might like to see that. Now, I believe I've shared a window in it. I believe that, no, okay, I can go get that. Let's see. I think I just need, y'all let me know if we lose the view here. No, that's the wrong one. I want here.
I need to get my own account, I think. I mean, how much do...
Gabriel, same question. Forgive me. I'm trying to remember where I put that. I thought it was in here, but I am not.
I have a comment about Jonathan's question. SQL
Yes.
queries or pandas to explore the data. In general, what we used to do, even in software development, not only in data science, we use the SQL queries to present kind of raw data for our task. So I'm talking about collecting data, not only, there is multiple kind of queries. For example, I'm not talking about inserting or adding new data to the tables. So now even in pandas or another type or kind of data frame that can be used, but the SQL query in general, it's providing the raw data, and any kind of extra processing or extra usage of this data, it will be from pandas in our case. So whenever you are collecting or manipulating the data to present something raw, something, it needs extra processor, but it will be faster to collect. That means you can go for SQL queries to get the data in faster way, because it will be all used on the engine. And once you have this data, extra processing, it will be part of the pandas. So it's case by case exactly, but in general, we are collecting raw data using SQL queries, not processed or ready to go data.
Yes, agreed.
So in that way, so you could run your query, you could do a group by and a join, or you could do a simple aggregation to bring it in, but you wouldn't do anything more than that.
If I understand your question correctly, Jonathan, and help me by letting me know if this answers you well, what Geith was saying was very important. Because of the next step in our process, we may not want a pandas data frame. And like I emphasized at the very beginning, this is one method. Now, we can also use SQL Alchemy to return data as a list of row lists. We could set up a Python dictionary in the way that we did it. And we can do all that with list comprehension and dictionary comprehension. And once you're in pandas and you're operating inside pandas, it can be very fast. But as you saw, the extra work to do the query and convert to a pandas data frame, that can slow things down. So what I think Geith was emphasizing, and I think the best answer to your question, is just to remember this is one way. It's an expedient way, because in machine learning engineering, we frequently go to a pandas data frame because of all the great routines that pandas gives us to study the data. Now, I want to pause and just say, Geith, do you have anything to add to my answer to Jonathan? And then we'll go to Jonathan to see if we answered. Okay, good. Jonathan, did that help, or is there more?
Perfect, thank you.
Oh, good, excellent, wow. Okay, now this is the Kaggle house prices data, and I'm doing some fun things here. I'll go through this briefly. First, I just find the current working directory. And I say, because, by the way, Visual Studio Code can be a little strange on what it regards as the current working directory when I run the code up here with the run button over here. And so just to avoid those issues, I go ahead and just tell me your current working directory, and I'm going to tack that in here, and then I'm going to go get my data that I know is in this directory. So it's just a simple way to get to the data. I read the CSV, I get the train and test data, and then I instantiate that same class we've been going over. Can y'all see this? Give me a thumbs up if you can see it, what I'm talking. Okay, good, because I didn't know how Zoom was going to treat it. Now, for table name and data frame in train df, so because remember, I use pandas to read a CSV and create the df. I'm being lazy here, but I'm being good kind of lazy. I'm being programmer constructively lazy to say, I know I'm doing the same operation on the train data set. I'm going to call the tables train and test, and I've got my train data frame and my test data frame. So that's why I did this way. And this is one of the elegant things of Python. You can do a double variable in your for loops if each element of the thing it's grabbing for also has two elements. So the first thing I'm doing here is just dropping the table exists. By the way, I'm just doing that because this was development code, and so obviously I hit a lot of errors and logical problems until I got this all troubleshooted and working right. But now I say, if the table doesn't exist, which it doesn't because I deleted it here, so I could comment out this control slash, but I'm going to leave it in there for now. And then there were some issues I found, so I automated the data cleaning. And by the way, we could do this for more variables, but for now, and we could do this replacement in a loop, but I'm saying SQL does not like this, or pandas, or one of the two. So I had to say, well, you know what? My mouse is acting bad. When you see first, replace it with first, the word form. When you see to ND, replace it with second, etc. So I found these specific cases in there, but you could build up a whole big set of common replacements to make this go better. And then you say for S in list of DF columns, I'm just doing this to be safe. DF columns is not a pandas, it's not a Python list. I'm just converting it to a list for safety. And then now I'm saying those are the column names, and replace the data frame, whether it was currently the train DF or the test DF, replace that data frame, those data frame columns with these new column names. But again, it's only going to do those replace if it sees those cases of 1ST, 2ND, etc. Then the data types, I'm replacing the data types so that I can push this data frame to SQL. That's what's going on here at first. I'm getting this all ready to go, this data frame to go into SQL. That's all that's happening here. So I'm saying, when you see 64, replace it with nothing. In other words, get rid of 64 because the data frame object types are different. And then replace object with var char max. I just found that was the best way to do it. Replace int with big int. And for T, for all of this is being done for this T right here, I'm turning it into a string, but I'm getting that from the list of DF types. And so these are the data types in the data frame. Now, when you're learning something from someone else's code like this, it's very instructive to take this step by step, comment out everything else, and just figure out, oh, why are they doing that? Oh, if I try to push this data frame into SQL with those things, it's going to barf. That's why he did that. Oh, if I use these pandas object types, it's going to barf. So that's why he did that. That's all that's going on. Okay, now that we've got those, and I think we're going to run out of time. But this was an exercise to push the data frame that I imported to SQL. We're doing all these things. I created this table schema with the column names and types that I created right here. And look at this clever thing here. This is just a list instantiation of putting this. I'm basically building up this right here. I'm putting that big thing in here, column names and types. This is creating a table schema on the fly with the table name I passed in. And then it's finally doing the create the table with the schema string, and it's pushing that DF into the database with that table name. Now, understand, all this work up here was nothing more than to dynamically create this part of the schema string. The rest of it's kind of easy. There are other ways to do this. We could have just pushed the data frame in after fixing these column names and then re-indexed the table. And that's a good way to do it too. I haven't decided which way I prefer yet. But now that we're done with that for both tables, excuse me, for this particular table, we go DF from SQL. Now, I only need to run the stuff above once for each table. That's why should have a, that's why I do this. So if it, I can comment this out, and if it already exists, I don't redo this table creation. But now, DF, the data frame from SQL, I query the DF according to the table name, and then I'm just going to drop that ident because I don't need it. I'm going to just use the indexes in the pandas data frame. And this in place equals true, meaning we could have passed this new data frame with that dropped column to a new data frame name. No, I just want it to do in place. And this is where the documentation is key. If there's a new thing you're trying to do, go check out the documentation for drop in pandas. And then, oh shoot, we're close. So finally, for label in the list of columns, I've got a test just to make sure that the two data frames are equal. I just wanted to see that the original data frame and the one I got back from SQL are the same after doing some careful things, and you'll find that they are in fact equal. Any questions before we hop over to mentoring and take a little bio break? And I hope this was helpful. This was a more extensive, close to real world example, but you wouldn't normally, you might actually want to push something to SQL to store it, because now you've got your data engineers taking care of that data. But now we later pull it back, but we wouldn't normally do that all in one operation. I'm just showing how you would go about those separate steps in one file. So any questions? Okay, good. And I'm sorry, I looked at the wrong comment. I know that was a lot to listen to on this last example, but when we share this, if we break this down for you, it will be very clear, I'm sure, if you play with it step by step. Okay, I hope you